Alright, today we're talking about trapezoids and kites. Objective, I will learn to use properties of trapezoids and kites to solve problems. And we're going to start by defining what a kite is. And a kite is a quadrilateral with exactly two pairs of congruent consecutive sides. Alright, so what that looks like is like a typical kite. You do have two pairs that are congruent, and usually it is these two smaller sides that are congruent and these two pieces over here that are going to be congruent. Alright, so now let's learn something about, or some properties about kites. If a quadrilateral is a kite, then its diagonals are perpendicular. So we draw another kite. Let's go ahead and label this A, B, C, D. Alright, so there's my kite, and if I go ahead and I draw these diagonals, here and here, my conclusion, so if I have a kite and I were to draw out the diagonals, then the conclusion would be that segment BD is perpendicular to AC. So which again means that these angles are 90 degrees. Next theorem, if quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Alright, so if we draw our kite, and I go ahead and label this one again A, B, C, and D, then the opposite angles, usually the pair that's congruent would be angle B would be congruent to angle D. Alright, so now let's look at an example. Find the measure of angle 1 and the measure of angle 2. Okay, well, since it's a kite, I know all these angles are 90, so the measure of angle 1 is equal to 90 degrees. And then kind of the reason would be the diagonals are perpendicular. Alright, now for angle 2, since all these are 90, this is 90. Okay, if this is 60 and 90, this one has to be 30 because the 30 plus 60 plus 90 has to be 180. Right, so 60 plus 90, subtract 180, you get 30. Alright, now because this right here creates an isosceles triangle, and I know that because these two sides are congruent. If this angle up top is 30 degrees, the measure of angle 2 is also going to be 30 degrees. Alright, next kite example that we're going to look at, I have this example and it says find the value of x. Okay, well, looking at it, there's some information here. I do notice, remember, the diagonals are perpendicular. Okay, so for this, I'm going to focus on this smaller triangle here. Because I have this right triangle, I'm going to say that I know 2x plus 10x minus 6, this has to be equal to 90. So 12x plus minus 6 is 90. Add 6 to both sides. And then divide by 12, and it gives me that x is 8. Alright, so some couple examples on trapezoids. Now we're going to, excuse me, kites. Now we're going to move to trapezoids. Alright, the definition of a trapezoid is a quadrilateral with exactly one pair of parallel lines. Alright, so let's draw this. Okay, I have two sides that are two sides that are parallel. Okay. Now, the bases are the parallel sides. So, for trapezoid, we have two bases. We're going to call this top one, we can call that base 1. This bottom one we'll call base 2. Right. And then the non-parallel sides are called legs. So this would be a leg, and this would be a leg. All right, and the angles at the bottom, okay, these would all be base angles. All right. Now, let's look at an example of a trapezoid. We want to find the value of x. Because these two here are, these two lines, or these two bases are parallel, these two are going to form same side interior angles. So we would have 12x plus 3 plus 13x plus 2 has to be 180 degrees. 12 and 13 make 25x plus 5 is 180. Subtract 5, we get 175. And then if we divide 25 into both sides, we get that x is going to be 7. Alright, next is going to be, we're going to define what's called a midsegment of a trapezoid. And that's the segment that joins the midpoints of the legs of a trapezoid. It's parallel to the bases. So if I have a trapezoid, right, these would be my bases, these are my legs. So I would find this midpoint here and the midpoint here. So let me kind of diagram that. And I connect that line right there. That's what we would call the midsegment. And that segment would also be parallel to the two bases. Okay. And we can actually find the length of the midsegment or the median, same word. These two can be used kind of interchangeably. Median and midsegment are the same thing. The formula for that is going to be base 1 plus base 2 divided by 2. Okay, so I would add the two bases and divide by 2. All right, so let's look at an example. We have a trapezoid, and segment EF is the median. Remember that I could also call the midsegment. And we want to find each of the following. All right, so if AB is 25 and DC is 13, I want to find EF. So I would do 25 plus 13 and divide by 2. So that's going to give me 38 over 2. 38 divided by 2 is going to be 19. So the distance for E to F is 19. Right. Next example. If I know that AE is 11 and FB is 8, what is AD? All right. Well, because this is a mid-segment, if AE is 11, DE is 11, which makes AD 22. And if BF is 8, FC is 8. So BC is going to be 8 plus 8, which is 16. All right, now let's change things up. So now I'm saying that B is 29 and EF is 24. I want to find DC. So for this, I'm going to let DC be x, and we're going to solve for x. So let's say I know the midsegment is 24. That's going to be equal to x plus 29 divided by 2. Alright, so we got to get rid of this fraction, so I'm going to multiply both sides by 2. That's going to give me 48 is equal to x plus 29. Alright, I subtract 29 from both sides, and I get that x is going to be 19. Alright. I'm going to leave these two for you to do. D and E, I want you to try to solve those, and you can check with me when you're in class. Alright, I'm also going to let you try example 5. I did an example like that for you just now where you have to find the midsegment. So I'll leave that one up to you. Because we're going to talk real quick about isosceles trapezoid, and that's a trapezoid with two congruent legs. That's kind of more of what you would consider to be, I guess, like a standard trapezoid, or the more common trapezoid, where these two legs are the same length. Right? And when you do have a trapezoid, or an isosceles trapezoid, it's exactly one pair of parallel sides, which is going to be these two bases. Same formula for the midsegment. It's going to have half of the base 1 plus base 2. The legs are congruent. Okay, and then you know that the diagonals are congruent. Okay, and the base angles are congruent as well. So that means this angle is congruent to this angle, and this top angle is equal to this top angle on the right. Alright, so now we're going to look at an isosceles trapezoid and try to find some things out. So if I got angle ADC, if that's 54 degrees, then because it is an isosceles trapezoid, that means angle BCD is also 54 degrees. Alright, now if I know angle BAD is 112 degrees, and I want to figure out what angle BCD is now, we're going to have to take 180 minus 112, and we get 68, so angle BCD would be 68 degrees. Right, and then for the next example, if angle ABC is 95 degrees, then we're looking at ADC. Same idea. We're going to take 180 minus 95, and that gives us 85. So this angle here, angle ADC, is 85 degrees. All right, we got two more examples. DONE is an isosceles trapezoid if the measure of angle EDO is 110. So this angle here is 110 degrees. And I know DEN is 15x minus 5 degrees. All right, we want to solve for x because these are same side interior. That means that 15x minus 5 plus 110 is 180, which gives us 15x plus 105. When we combine like terms, subtract the 105 from both sides, we get 15x is 75. Divide by 15, and that tells us that x is 5.